All right, cool. Here we go. So yeah, this is the second part of lesson 4. You guys still all on there? It went sort of quiet. Okay.
Yeah, I'm here.
Cool.
Yeah, here.
So cool. Yeah. So we got a few of us here. So this is so last time we kind of looked through. We wrote this simple crawler, and it was really slow. And so I won't review that now, and I've got my screen on the text editor here, so I won't go into it. But it was really slow, and the reason it was slow is because it was just sitting on, it was just trying to read from a socket, and 90, it was something like, when we timed it, it was, if you let it run a long time, it'll get to about 99% of the time, it's just sitting and waiting for the socket to receive some information. So in order to speed it up, we made a little a multi-threaded crawler that could kind of have a couple workers at the same time, or have a couple different kind of tasks eating from the queue at the same time. We actually did that, right? Did we do that at the end of the tutorial?
Yeah, at the end.
Okay, good. I was kind of blanked out there. So I can never remember like what I wanted to do and then what we actually did. So yeah, so it was better, but we want to kind of get to we want to write a program where we can have lots of workers, like a couple hundred workers. And so if you guys pull the latest changes, if you look here, if you can see this, can you guys see my cursor?
Yes.
Okay. So
yes.
IBD4 crawler.py. That is the file you guys want to open. So you want to go find that file and open it in the text editor or something of your choice. I'll give you a couple seconds to do that.
Sorry, how do I pull the latest again?
So you probably want git fetch and then git reset -- hard origin master. Git fetch is just like it'll go and see what the origin what has happened recently. It'll just go update that.
Got it. Okay.
And everybody have you got it figured out? You got the file open and pulled, Gustavo?
Yes.
Okay. John, how's it going?
Yep.
Yeah, Justin, I haven't had a chance to watch part 1 yet.
Okay, that's cool. Well, you can watch that. You can just go watch through this one. We'll do this one together. You might get a little lost, but it'll be fun. So, have you opened this file though?
No, I'm still trying to pull.
Okay. Well, Alex and John, once you do it, tell me that you got it. Those commands are up a little bit on yesterday's Slack messages. Git fetch, git reset -- hard origin / master.
Okay. Cool.
Yeah, you guys.
You got it, Alex?
Yeah. Now I just got to open my text editor. But yeah.
Yeah, you can continue, Justin. I'll catch up in a second.
Okay. Well, it sounds like we got them open. So yeah, let's see. This is kind of this has become a bit of a monster. It's a pretty big. It's no longer a tiny little app anymore. But I'll just kind of start from the top and go at the high level of what's going on. So if we just go to the, in a Python program, if it's going to be run like, when you run it, it's good to look at this if underscore underscore name equals underscore underscore main, or dunder main. We say dunder if it's 2 underscores in front and the back. And so these are like the kind of hidden. There's a lot of hidden attributes in Python that look like this that make Python work. Like they're how, well, remember when in the first lesson we were looking at modular arithmetic, right? And remember we looked at this, or in lesson 0, we looked at, we showed how dunder mod was how modular arithmetic worked. And when you create instances, this dunder init is how they're kind of modified. And so in Python, this dunder name equals main is a condition to check if this was run like directly from the command line. So for example, if it checks if it wasn't imported by another program, right? So if this was run directly and it wasn't an import or anything like that, it'll run into this block of code, and this one just checks for an argument. There's two ways you can run it. One is a crawl, and one is to kind of monitor the progress of your crawler. And so we're just going to be concerned with this one here. And so what it does is it sets up our database. We have a SQLite database, which is like kind of the simplest form of a SQL database. SQL is like is just like the standard way of interacting with a database, and it's been it's a technology that was invented like in the 60s or 70s, and it's really, really proven and is great in a lot of circumstances. And SQLite is actually the most, I was just learning more about it recently, it's the most deployed piece of software in the world. There's like probably 10 billion copies of it out in the wild. Every Android phone has one. Almost every internet-connected device has one, has a copy of SQLite. So it's a pretty amazing little program. And so what we do is we just create some tables, and I'll go into that later. And and in SQL, tables are like the different types of data you're storing. They'll all have their own table in SQL, and then the tables are related to each other. And that's how you can have a big, have a bunch of stuff in your databases, have a bunch of small tables, and they're all kind of related. And so we create some tables, and we actually delete the old ones. And then we create a couple addresses. This is a little goofy because we're reusing the address that we wrote in actually, I don't think I ever had you guys do this, but when we read an adder message, this is I guess we did do this. This was in lesson 2 when we were doing the version messages, remember? I can show you. So I think I can, yeah, so this is the class we wrote, remember? It takes a couple arguments. It just has services, IP, port, and time. Those were like the ones that we did before. And we just had this like from bytes, from stream way of reading these addresses. Do you guys kind of recall this sort of thing?
Yeah.
Cool.
Yeah.
So the one thing you'll notice is that like, it's like a, so if we want to reuse this class, it would be nice if this was kind of a general purpose address. And then like we could, so these are the two important ones. And then we could also use services or time in certain contexts. So so this program now, like it doesn't really have a notion of services the same. Like these addresses are more just the IP and port. And so I just passed in none for those two, for the services and time. It's a little hacky, and in the future I'll probably find a simpler way to do it. But this just creates a list of addresses, and then we insert them into the database, right? And so our database will keep track of a couple things. It'll keep track of addresses that are like known or potential, that someone says or appears in the Bitcoin network. It'll keep track of connections we try to make to those addresses, and then kind of the outcome of the connections. Did we get a version message? Did we get an adder message? What were the messages? And so I'll get into that later. So we just put some addresses in the database, and then we just say crawler.crawl. And with this crawl, we pass in one argument, and this is how many workers we want. So let's put this up to 500. And so let me think. So this is what it does. It just creates this little crawler thing, and then it'll go on crawl. And so let me give you kind of a, before we jump into the code, let me give you a better taste of like what the database actually looks like. So I'm going to try to switch screens here and go to my SQLite. Okay, can you also, did you see the screen kind of change?
Yep.
Okay.
Yes.
So let's, so we don't want a, and this was the program I was saying to download. So actually, if you can follow along if you downloaded this program. It's called just SQLite Browser. And if you don't have it, you can kind of try this again later. And if you look at the base of the repository, there will now be an overnight.db file. So if you go and find that, so this was what I did is I ran this script overnight last night, or actually, at least I think, let me just, do you guys see this file? Yeah, so it is overnight.db is in the base root, the root of this Bitcoin Core repository. And you can actually open it. It's just a .db file. It's 1 megabyte. So it's actually a pretty small file. Huh?
I think I cannot see. I can see the SQL behind, but I just see a black box. I don't know if.
Yeah, I just see a black box as well.
What do you mean by black box?
Here, I'll send it to you in Slack.
Yeah.
You still sending it?
Yeah, it's sending right now.
What the hell is this? So this was.
Were you sharing your screen or just an application?
Oh no. Oh, sorry. Oh, that's funny. Okay, that's hilarious. Okay, I understand now. So that's what happened. Okay, thanks for showing me that. So I just hit the new open database thing here. You see this thing here, and bet you get the black screen again. And I bet if I do this, now it goes. It's moving around, right? So this is just the open. This is just the open dialog to open the database file. So yeah, if I just see a list of files, and I just go find my repository, and I can click the overnight.db file. It's just a menu. It's just a file chooser menu thing. That makes sense?
Yeah.
So I just chose that database, and the reason I did it is it was the result of running it for 48 hours, or for 12 hours about, and it was actually pretty good. It ran for okay, yeah, exactly. So Gustavo just uploaded one. You know, it's just go and choose a file. And so the cool thing about SQLite is that you can actually just have a file that has your entire database. You just like email it or post it to Slack. It's pretty nice, you know, comparing with like a Postgres or MySQL. These are like more more full featured databases. You can't just like send your database in Slack. Or on GitHub, it's a lot more complicated than that. So you guys can actually access this database. So if you pull it up, you'll see this. You know, there are a couple tabs here. Structure is like what tables there are, and so I guess let's start there. Can you see this all right? It seems like the font might be a little small.
Looks good to me.
Okay. I can't zoom. So yeah, so. We got 5 tables here. The most important one is probably these addresses, right? So these ones just have an ID. And so the reason why you would need IDs in a SQLite database is like they're how you define relationships. So this doesn't have actually any like specific data. This is just how we can like define relationships between the tables. Because everyone gets a unique ID. And here we have IP and port. So that makes sense, right? The addresses would have an IP and port, right? IP is of type text. Port is type integer. Also makes sense, doesn't it? Then we have this connections. This is like, connections is like every time we try to connect to one of these addresses. So how our program is going to work is anytime we see an address that might be a Bitcoin address, we're just going to dump it in the database. And then we're just going to basically like loop over these addresses forever, or like according however we want, arbitrarily, and try to connect to them. And every time we do, we're at the end, we're going to create a row in our database called connections, and that's going to say like, hey, which worker did it? What was, you know, which one of our workers did it? When did they start working? When did they stop? Did they get an, like, what was their error if they got one? And which address were they working on? So you see how we have, that's why we have address or ID up here with addresses. So then we can kind of define our relationship here between connections and addresses. So that makes sense so far. Any questions about that?
Makes sense.
Sounds like it's making sense.
Yep.
Yeah. And so then
so.
lastly, we just have the version messages table. And this is really simple. It's like, let's just get the raw blob. So the raw bytes that we got from our peer, let's not even try to decrypt it yet. Or let's not even try to pull out the various things. You know, in the future, this would have like version, services, add or receive, add or from, all the things that were in the version message, all the specific things, you know, relay, all those things. But right now, let's just save the raw blob because we want our program to be simple and get it working while it's simple, and then add more features in later. And once again, we see an ID. Well, this is the connection that we were talking to. So you see we kind of have like, you know, addresses are related to connections. Connections are related to version messages. And so we kind of have a nice, clean structure to our, you know, the relationships to our table. And addr messages is practically the same. Raw is of type blobs, so just put whatever you want in here. And connection ID, same as version messages, you know, which connection was the one that got this addr message. So there you kind of see it, like our program's going to start with a couple addresses, right? It's going to connect to them. It's going to save the kind of the outcome of the connection, and that'll include addr messages or version messages, or maybe an error if you know, depending on how it went. And if it does find addr messages, it's going to go and add more addresses back into the database, and then we can just go again and again. And so, does that kind of make sense? The kind of the layout of our database table.
What will it do, or is this even possible that it would find multiple, that it would try and like connect to the same address multiple times?
Yeah, so that's actually fine. I mean, you know, we can, well, there's kind of two different ways you can think about that are, so the first one is, you know, we could just every 5 minutes, we could go loop over every address we have and see if anything's changed, you know? So every address could have 1,000 connections associated with it, and that's fine. Does that make sense?
Yeah. Is the database organizing, like, will it group connections from the same address together, or does it not really matter?
So the database doesn't. The database is stupid. It just stores them. But SQL will allow us to make that query because we know the address ID associated with every connection. We'll actually be able to write, and I'll show you how. We'll be able to write a SQL query that can, you know, just pull out all the connections associated with one address. That makes sense? Got it.
Yeah.
So that's a good question. And the other way you can think about it is like, well, would it be possible to put two different addresses in here that are the same? You know, like what if we had IP, you know, XYZ and then port 10, whatever, you know, like let's just say we had that and we tried to stick it in 2 times. if we tried to stick it in the second time, it would actually not accept it. And that's because down here, I created an index, create unique index. That's the name of the index on port and address, or on addresses, sorry. The name of it is ID, index, address, IP, and port. So you don't have to know exactly what all this means. But the important thing is I create this this index. The index uses this unique keyword, and it has IP and port as its kind of arguments. And so what this does is it makes it so that every entry in our database has to have a unique pair of IP and port. So if you tried to stick, the same IP in twice, the second time it would actually fail. So we know that every address in our database is going to be unique now. That kind of makes sense? I'll take that as a yes. Okay, cool. So
Yes.
we can kind of move over to this tab, and browse data will just allow you to kind of go through every table and look at what you got. So if we go over to addresses, these are all our addresses. It kind of looks familiar. Most of them are IPv4. Every once in a while, here's an IPv6 address. So every once in a while you get an IPv6. No onion addresses, because I still don't know how to connect to the onion addresses. The Tor addresses. But you can see we got quite a lot of them, right? We're already at 800. And so here we go to 1,000. So we got 2,800 unique Bitcoin addresses that were up last night and that we found, and so that BitNode's website has about 10,000. And so just last night, I got a quarter of the way through, and the way they see it. And I'm sure some of the BitNode's addresses, go up and down, and some of them are onion Tor addresses, so I haven't seen them. And you look at most of the ports, and they're almost all the same. They're all 88333. That's the default. And so you see that you can change it if you want to. You can run it on something else. So
question on that? When we see statistics around like how many full nodes are being run, is the way to tabulate that to like do something like this? Yeah,
that's the only way. You'd have to go and find them all, and that BitNode's website is probably the most the best attempt at it so far, at least as far as I know. It's just an open source Python crawler that's they've been working on it for a couple of years, so it can find most anything that's advertised. So yeah, exactly. There's no, since it's a peer-to-peer network, it's like there's no authority that keeps track. You just have to go and you just have to go and have a look for yourself, which is really cool, I think. And it's different, Usually you think of some authority figure that can tell you this. So yeah, that's a good question. This is what you get in addresses. And if we look at connections, so addresses, we have connections related to addresses. So let's just move to those next. And if you look, first thing you'll notice is that this column is all empty. Oops, sorry. See, this column, the stop column, is all empty. At least this is what I noticed first. This is because I have some bug in my code last night that wouldn't save the stop time. So that's a bug. But it's kind of cool. You could see, hey, this is which number. Remember, so I had 500 workers. And so you can see that basically, you don't see any repeat numbers, at least I don't here. You can see that every one of these kind of connections was handled by mostly different workers. And here's the time, like the Unix time they started. And this is, remember, just like second sent some, excuse me, second sent some time in like since 1970 or 1971 or something. And so once we get this stop column to work, it'll be kind of cool. We'll be able to actually see how long the average task takes, and how we'll be able to go and kind of pick out the ones that are really slow, and we'll try to figure out, well, why are they slow? Is it, does it have anything to do with which thread is running it, or are certain peers slow? Like we run it multiple times. Could we go and look at a given address and like say, was this one always slow? maybe they have a crappy computer, maybe they have too many connections or something, who knows. And so here are some errors. You see that first off, there's a lot of errors. And network is unreachable is a big one. I think that means they're just not connected to the internet. And this bad magic bytes is a kind of a bug in my code. It's sometimes I'm not parsing these messages correctly. But you can kind of look, it's pretty cool. This one's taking too long. I give it, last night I was giving it 180 seconds until it found a version message, or until it found an adder message. And if it didn't get an adder message in 180 seconds, I'd just give it an error, say, hey, it's taking too long. Let's go to the next. Let's kind of quit. And timed out means like we connected and I was waiting for them to send me something and it just took too long. So you can kind of see all these different errors. And one thing that's great about a little SQL database is we'll be able to say, well, hey, which ones are the most frequent? And then here's which address you were connecting to, right? So we'll be able to kind of go through and see, kind of take a look at all of them. This is kind of weird. Oh, you can kind of see, can you see how the numbers get bigger over time? So here at the top, numbers are all single digits, right? And you see as we go, now there are a lot of them are double digits, some triple digits. As we go further, now these are all triple digits. And now we're up in quadruple digits. And so you saw we had 2,800 addresses, and none of them, we don't even get to 2,000. So it looks like sometime in the night, my worker ran out of, like there was another bug where a lot of the tasks would just stop. I still don't know why they were, what was stopping them. So you can see it's kind of interesting. We only got through about half the addresses we know about. So you got to think if we got through that other half the addresses, we could find a lot of new peers. That's kind of interesting, isn't it? So this is
Wait, sorry. Can you rephrase, say that again?
Yeah. So you see how the address ID here, it only gets up to about 1,000.
Yeah.
But when we go and look in our addresses, if we scroll all the way to the bottom, we got 2,800 different addresses. So ID goes up to 2,800. And so our crawler last night only got to about 1,000. If we go and look at our connections, in this address ID field, it only ever, it just goes up and up. And here, this is about as high as it gets, like 10. So here's 1105. That looks like, so here's just, this is the magic of SQL. Like our question is, well, how many of these did we talk to? And so here's how you kind of figure that out. You can go like select count of star from addresses, or from addresses. I think you could just do group by address ID. Let's try that. No, sorry. We want count. I think we want count of address ID. I haven't done any SQL stuff in like a year or two. Okay, that's not right. Oh, we need unique. How do you get? Let me think. Let me look this up.
But basically, those two like sheets you showed, one is everything that we've been told about, and the other one is everything that a worker tried to connect to. Or tried to go.
So the connections were everything we tried to connect to, and then the addresses thing was everything we know about.
Right. Okay.
Can we do select distinct? So this is a huge hack, but I think it should work. Yeah, so there we go. So we selected 1,112. We connected to 1,112 addresses total, and how this works is like this is a bad intro to SQL, but like we have this subquery. We just say select distinct address ID from connections. So we just get like all distinct addresses, and then count of star just says like how many. It just counts how many you're selecting from. So this is a terrible example of SQL if you don't know SQL. Oops. What did I do there? Yeah. So, but it's cool. Like we can. If you don't know this, you can learn about it. But that's our answer. So we went to talk to 1,112, and so if we go hit this new button, create a new query, you know, from select count of star from addresses. So there you go, 2,800. So you know, we talked to about 11 in 28 addresses. So that's a pretty low percentage. So that's kind of interesting. You know, if we let our program run longer, if I could figure out that bug that's stopping some of these tasks, we'd be in pretty good shape, huh? So we'd find a lot more. So there's a little examples. These are the different kind of tables we have, and so so does that any questions about that? Does that kind of make sense?
When a peer tells us about something that they know about,
yeah,
are they? I guess does that mean that doesn't necessarily mean that they're currently connected to that node, right? That just means that they have at some point in the past heard about them.
Yeah, I mean that's a good question. It's like one of the things that I want to kind of explore with this project is like just anecdotally from running it, certain times you'll have most of the time you get like one or two peers. You get the adder messages have like a couple entries in it, and so every once in a while you get one with like 1,000 entries in it, which is really, you know, that guy is probably not connected to 1,000 people at once, right?
Yeah.
He's probably sending everything he's ever heard about, or at least he's just keeping track of the 1,000 most recent, and as he adds one, he bumps one off the back or something. And so every once in a while you get that, and it's like, well, what's going on there? You know, is this like, you know, maybe it does like BTCD, or is that like Bcoin, I think is the JavaScript full node? Like, does one of these other full nodes, like it would be interesting to look, you know, to associate every one of these large adder messages with what their kind of like user agent was, or their version number, or from the version message they give you. Like, try to figure out where, you know, what software are they running, because they behave so much differently than everyone else. And so, yeah, to answer that question, it's like you can't even say, you know, what your peer is going to do necessarily, because all the you know, the different implementations will behave a little differently. And you know, for this, for example, the Bitcoin protocol is pretty permissive. It lets you. I mean, I think there's the max you can send is like the size of is maybe like a TCP max message size, which is pretty big. I don't know exactly how big, but I mean, it's at least a megabyte, because you can send megabyte-sized block messages. So, so yeah, I don't really know the answer to, or I don't really know exactly what's going on. But if we get all this data into a database, we can figure some of that out.
Yeah.
Any other questions? Okay, cool. Well, I'm going to just kind of show. Let me just see. These are just some I was like running last night that were kind of interesting. Yeah, so this one was kind of interesting. Like, so this will go and count it'll join the addresses. You remember we have these two different tables, these connections and the addresses. So if you want to query both tables at the same time, you use this join command. You just say I want to join the addresses and the connections. And again, like there are a lot of tutorials online that are going to explain this better if you haven't encountered this concept before. But just like kind of take my word for it, this is how you query across multiple tables. And you say, hey, I want to then group them by address ID. So like basically, this is what kind of Alex was asking about earlier. It's like we're just going to get a bunch of rows. Let me kind of show you. So like, if we just hit star, this will just select everything by when you join across these two tables. So what you see is like it's a concatenation of the addresses and connections table. So over here is all of the connection stuff, and then over here is all the address stuff. And so let me think. Order by. Or maybe. Okay, that's not what I was expecting. I thought we'd have multiple for some of these. Okay, well, I don't know exactly what's going on there. But I guess maybe it's only taking one. I'm not sure. So my SQL knowledge is a little out of date. But so this is what it kind of looks like when you just select everything when you join the two tables. So this was going to just say, basically, how many times did we connect to each address? And so for example, this one, it looks like we connected to this one 67 times, which is kind of weird. So I don't really know what was going on. If this is doing what I think it does, it's like for certain addresses, we were connecting a lot. And then for other ones, we were connecting little. And this actually doesn't include any of the addresses that we're never connected to. So this is an incomplete query, but I think it's kind of interesting. Here, let's see how many version messages we got. Oh, look, we got 3,061 version messages. 3,761 version messages. So that's kind of cool.
Wait, so are we connecting to that one 67 times because 67 other peers told us about that specific one? Is that what that means?
I don't actually know. I'm actually a little skeptical that this is correct. I might have screwed something up here, but I mean, from this, because like I don't understand why I'd be connecting to certain ones a lot and other nodes like none. And so, I mean, this is like, I'm showing you guys a project that's still kind of buggy and really alpha level, but maybe in like another week or two, this crawler will be properly decent. But yeah, so I don't know, like when we go a little later, I'll show you how we were getting these addresses out of the database. And I think there might be a bug there, but yeah, so I don't know. It probably shouldn't happen. And so, but let's just kind of continue. So this is another query that would basically allow us to, I think this one might actually be running on a different database when I fix. But yeah, how this one would work is like, we'll say, you know, for every worker, you know, we're going to go look at all the workers. And then we're gonna say what's the maximum time that they have like a connection that's been started, right? And then let's go take the difference between now. This is how you do now in SQL in this format, and minus that time. And so basically, what this does, this is the difference from now and the last time they started a task. And so this column is how long have they been doing nothing? And since I stopped this in the morning, like. About 10,000 seconds have gone by, but you'll notice that you know most of these are pretty close to each other. But at a certain point, see, there's a certain point where there's this big gap, and all of a sudden you have these ones where these ones have been silent for like 4 times longer, and we're at about worker number 100. So 400 out of my 500 workers were, basically crashed within probably a short time after I started this program. So it's kind of odd. Like, see, these have all been dead for 48,000 seconds and 48 or 49. So that's about probably when I started the program last night. And then a lot of these have only been dead for 1,000 seconds when I stopped the program this morning. So this is kind of interesting. This is me trying to debug why some of my threads are dying. And so, yeah, this is maybe too much information. And here's an interesting one. Like, let's see how many times we encounter each error. So here's failed to recover from bad magic bytes. Remember when our messages parse these magic bytes to start? Somewhere in my program, I'm getting off. I'm losing. The beginning of the message is off, and then I try to recover, and something breaks. So I think some of the time this is when our peer hangs up on us, when our peer just stops sending us any information. And so this is happening quite a bit. The other one is taking too long. This is when it just takes 180 seconds to get an adder message and they don't send us one. And so we're just going to be like, well, screw it. We're not going to listen any longer. Network is unreachable. Their node is down. Connection, maybe their internet's bad. Connection refused. They have too many peers already. No route to host can even, I'm not sure exactly what that means. List index out of range is a bug in my program. This is when I'm trying to get the 5th element in a 3-element list or something. And so yeah, this is kind of cool though, isn't it? You can see you can start to see all these things that were, you can start to see about the kind of the network, like how many, like what percentage of the nodes are down at a given time. It's kind of interesting. So yeah, let's pause there, and after this I'll go show you some of the code if you're interested. Any questions about this kind of stuff?
Which types of errors kill the workers?
So the way it works is every worker should, well, this is a good segue. So every worker, so this is what the workers do. Their code is very simple. It just gets the next address. It makes a connection. It does like the main. It runs the connection, and then this just like sends back the result of the connection. And so I'll explain that in a little more detail later. But the important thing is this connection.connect. And that's these two methods up here. And you see there's a lot of try except here. Like the way this works is it should never, like the worker should never die. Anytime we encounter an error, we don't, like an uncaught exception in Python will cause your program to end. And so with something like this that's going to run for a long time, you don't want anything to stop your program. You want it to just keep running, and if it encounters an error, this will just take a note of it and actually put it in the database. And so there actually shouldn't be any types of errors that kill the workers. So it's not that the workers are actually like, I don't think it's they're actually dying. I think they're getting hung up on something. Like there's some thing they try to do and it just doesn't work and they just get stuck. So I actually don't know what the problem is. This morning I was just kind of debugging it and trying to figure it out. But these threads are kind of tricky because it's not as easy as regular Python, because you can't just, if a thread is off doing something, it's a little easier a little harder to figure out exactly what they're doing. So I'm just kind of learning how to do that. That kind of makes sense?
Yeah, definitely.
Yeah, so now that we're over here, I'll just kind of give you a rundown. So the file basically has like 5 things in it. First is this connection class. Well, I guess first is we import address. So this is the kind of the address thing that we're always dealing with. This is the same address we dealt with in lesson 2. This is just class. Then we have this connection. The connection is like, every time we attempt to connect to the network, and so it has an address associated with it, like who's it trying to connect to. This is just the name of the worker, just to, you know, make it a little easier to kind of figure out who is doing what. You know, for example, we could, you know, figure out if we can figure out which worker is stalled, maybe we can debug and figure out what that worker is doing. Here it makes one of these sockets, and, you know, all this does is it chooses the right version of, is it IPv6 or IPv4? And it just sets a couple, like it's 15-second timeouts, and this will just reuse sockets. This isn't important, but this just makes like a socket and sets the options we want. And here are the errors or the values you saw in the database, right? Start, stop, and error. And then here are the version message and adder message. These are the things that were stuck in the version messages and adder messages tables in the database. So you can kind of start to see where all these values are coming from. And so I'll get into how the code works, but that's just in terms of like a conceptual level. There's this connection, just like the database, and then there's worker. These are like the different threads. So these are the things that there were 500 of them. And the way they were, you know, you can see it's pretty simple to make a worker. Basically, all you have to do is you subclass threading.thread. So this is the main way to make threads, and you can just make a subclass of it. And all you have to do is define a run method. And then when you call when you create this and do worker.start down here, this is how you start a thread. When you start the thread, this thread subclass, it'll just go and the magic of the threading module will just call this run to kind of do the main kind of work. Does that kind of make sense? Anybody there?
Yep.
Yeah, so run is just a way to say like what you want your thread to do once you start it. And so then, you know, we have connection, worker, and here's crawler. This is like the thing that kind of controls everything. This is the thing that has, basically you just tell it how many workers you want, and then it'll go and, it'll basically go and create the workers. You know, it'll have the spawn workers, it'll go and create that many workers. And these are the two other really important things is when you're doing this threaded programming, you want to have, like this is the thing I wanted to try to explain a little better, but didn't figure out a way to do it. You don't want your threads to like access the database, because it's very easy to have race conditions and have, you know, one thread try to commit one change and another thread try to commit a different change. And these two changes are out of sync. You know, your different threads can't talk to each other really by default. And so you can get really out of sync, and they can just really destroy your database and just put in all kinds of things that don't make any sense. And so the solution to do that is to make these queues. You know, a queue is just a simple concept. It's just it's a little data structure that you put stuff in one end and you pull it out the other end, right? And so it maintains order. And so what you can do is you can have your different workers go and kind of communicate with the parent that spawned them, which we call the crawler. And whenever they finish their task or whenever they update something, they can just send a message across this queue, and then the parent can deal with the messages. And so this might be a little confusing. I wish I had my whiteboard mounted so I could kind of draw this out for you a little more. But this is a technique for allowing the threads to communicate with for the workers to communicate with the kind of parent crawler. Does that make sense?
Yeah.
Okay, that's good. I didn't think that was going to make any sense. And so the crawler.crawl, remember, this is how you run the program. It's actually pretty simple. It just goes and first thing it does is it spawns the workers. It creates these workers, which are just threads with a little specialized function that they run. And then just while true, so forever, run this forever. Check if this address queue, basically these are new addresses we found out about. You know, check if this is not So this is the thing that the workers will draw from. And so this is just work for the workers. So basically this says, hey, if the workers, if there are less than 100 tasks for the workers, let's go and add a few more tasks. And yeah, we can go in a little more detail later. But so that's one thing this main thing does. And then the second one is like, okay, have the workers finished any connections? And so if they have, they'll put it in this connections queue. And if there are any in there, this will just go and say, hey, let's for every one of them, while there's something, while this queue has a size, let's just go through every single one and save them to the database. And so then it calls time.sleep because this runs pretty fast compared to the workers. So every 2 seconds we'll get a little printout of what the status is. Does that kind of make sense?
To looking at the code, but yeah, it makes sense.
Okay.
Yeah.
Sorry, what's the? Can you explain again what happens if the queue size gets below 100? What action ends up being taken?
This one here. Yeah, this one here. That's what this thing does. This little block. This just gives the workers tasks, and this one just processes task results, basically.
Got it.
And so it is actually a pretty simple program. Like this is just a while loop. It just creates workers, and then forever, every 2 seconds, it'll go and check if the workers have enough work. It'll just a better way to think of it. This just ensures that they have work. If they don't, then it'll give them some more work. But it also, this will only add 100 addresses at a time. So it doesn't give them too much. We wouldn't, if we had actually it probably wouldn't be the worst, but so this will just always kind of give them more work. This one will say, hey, have they done any work? If they have done some work, let's see what work they've done and save it to the database. And so this is something that, you could try to do it in the thread itself, but sometimes the threads could get out of sync, and they could both they could write kind of conflicting results. And it's just kind of conceptually simpler if you only have one of your threads writing to the database, so they're not kind of competing. That makes sense?
Mm-hmm.
Cool. And so yeah, that's basically what the program does. And so we'll go back to the top here and look a little bit more at what connection does. Well, actually here, let's do this first. So if you go a little further down, then we have all these things that basically execute SQL statements, right? This one just basically deletes everything in our database, all the tables. So it just deletes all the data. This creates our new tables, and so you can see where we got the, why our tables look the way we do. Connections. Well, let's just kind of remember addresses had ID, IP, and port. This is why. This is how we just defined. Remember, I pointed out that index. You had unique IP and port on every address entry. That's because we execute this piece of code. So we just execute a number of SQL statements that basically configure our database. And so then these ones, this one just goes and saves a, when we finish one of our connections, this just goes and makes a record in the database. And it's pretty simple. It just, it puts it into this table, and it puts these values into the table. This colon and then something is the way in SQLite where you can pass in a dictionary. So if you see when we execute this, we have the first argument is query, which is this string. The second argument is args, right? And args is basically just the connection with most classes. You can call instance.dict, and it'll turn it into kind of it'll take whatever the parameters that object has and turn it into a dictionary. This is just a way to create a dictionary, and then we just add we just add one new thing to it, address ID, because that is also needed here. And we just grab it off of the connections address, connection.address ID. And so, yeah, this is how we put the connections into the database. And there's some kind of hacks. This is a hack. You don't have to understand necessarily all of this. And I'm going to probably change some of this as you know, over the next week or two. But so that's how we put addresses in the database. This is how we put this is how you put connections. And then, you know, whenever one of these connections actually downloaded a version message, this is how you put it in. This is how you put in an adder message. Remember, this was just that raw blob. It was just the raw bytes. And then this one, these two are this is how we put in addresses. We can put a bunch of them in. And sometimes, remember that index where we had everyone supposed to be unique? Sometimes this will raise an error if we put in a duplicate. So that's fine, because if we oh, we don't, that's not what we want. We want continue. If it raises this specific error, we just ignore it. We say that's fine. It's fine that we tried to put in a duplicate. We expect to get many duplicates, right? Because we're going to try to find every last one. So of course we'll get some duplicates. And here's next addresses. This is the one, remember, when we run up, when we only have 100 tasks left, this is how you find the next 100. Remember up here. This is what this one does. If there's only 100 tasks left, let's go get more. And this more will just try to get the next 100 or less, whatever's available. And that's kind of how it does it. And how it does it is it selects from address, limit 100, so give me 100 or less. And it just says, give me one where the ID is not in any connections address ID, if that makes sense. So if we look across all connections, let's try to find one. Let's ignore those, all the addresses that have already been connected to. So this is trying to find addresses that have not yet been connected to. And I'm pretty sure there's a bug in this, because as you saw from the data, it seems like this is not actually working. But yeah, so that's kind of roughly from kind of top to bottom how the program works. And yeah, any questions on this kind of on any questions on that? Are you super confused or kind of get it, or how you doing?
Man, Justin, I'm just trying to wrap my head around everything.
Yeah, that's fine.
Yeah, same.
Yeah, so I think the like I didn't really know how to teach this. Like I'm gonna have to figure this out. And but what I think would be kind of cool is if you guys could try to like run this on your own, and you know, try to kind of look at the SQLite browser and try to see kind of what you're getting. And you know, like for example, you know, yeah. When, how should we say this? Like, it would be cool if you could, you know, this table, right? Version messages. We just stick the raw thing in here. You know, could you update this so you also put like, you know, could you pull the version number out of the blob? You know, because we already know how to do that. Remember, we have version.fromBytes, that class that we made. Could you do, you know, remember services? We could make this an integer. You know, could you pull these out? You know, could you just try to kind of make some simple thing and try to get like a little bit more information in the database? Or could you try to, you know, just like play around with the different, you know, what happens if you just spawn a couple crawlers? What happens if you spawn a ton of crawlers? And yeah, so that's kind of, I think this is going to be something that you're going to have to kind of play with a little bit. And yeah, I admit that this is probably not the best way to teach it, is to just give you a huge chunk of code and be like, hey, try to figure this out. But That's kind of where I'm at. And but I think that if we kind of play with it some, we can, you know, it'll be an interesting experience for you guys. That makes sense?
Yeah, I will say, Justin, I really feel like I'm starting to appreciate Bitcoin under the hood a lot more after.
Yeah. So that's kind of
doing this.
that's kind of the goal, right? Is like try to figure out, you know, like for me, one reason I like to do this stuff is I become so much more confident that Bitcoin's like gonna work, you know? Because it's like, God, this is like, it's quite impressive. The more you learn about it, kind of the more impressive it is.
Yeah, it's the rabbit hole of rabbit holes.
Yeah. Gustavo, are you good?
Yep. I'm just trying to run, but without success. I will debug later.
What
More
yeah,
slowly.
so I think what you might have to do is I'll post it in here. To run it, I don't know why. Actually, here I can just so I can quit this editor. Can you guys? You can still see here. So let's see. No, I don't want to do that. Damn it. Okay. So I had to go to a different terminal shell. So this is how you'll be able to run it. It's a little confusing, and I can paste this into Slack. Let me just make sure it actually works first. Yeah, so here you go. Like, look, it prints out every one of these workers. Oh, I just started a bunch of workers, and so this just kind of keeps track of what the size of the queue is. So you know, you started with 4. You got some stuff happened. The address queue went to 0, so you ran out of addresses. Got back up to 4. Here we got some more addresses. So you can kind of, I should probably put in a little more logging, but you can kind of see we're slow, you know, we're kind of getting some stuff. And if we go to, this is the last thing, and then we can stop for the day. But if we go to, where is it? If we go to the database thing and we open that database, so this will just be crawler.db. If we open it, you know, and let's just see how many connections we've made. So we've made 81 connections. Let's see how many addresses we know about. We know about 41 addresses. So that's pretty cool. You know, we ran this program for like, you know, 30 seconds, and we've already, you know, we're finding at least one address per second. And, you know, okay, that's 20, you know, that's probably 2 addresses per second. So it's incrementing pretty quickly. Oops, database is locked. So I hit the button too many times. Okay, there we go. So it's still, but so yeah, there you go. So that's, did anybody else get it to run?
Not yet. I'm gonna have to do it offline.
Okay. Well, I just pasted the command to run it into Slack. So yeah. So you know, try to be you know, I'd suggest you be kind of active on Slack, and I can kind of teach you how to use this a little bit more, and I'll continue updating it over the next week. And yeah. So now look. Well, I guess you probably can't see, but now my queue has 129 messages in it. I mean, it's getting pretty big. Yeah, we know about 161 addresses. We started with 4. Now we know about 161. So we're crawling like hell right now. So pretty cool. All right. Well, that's all I got today. It's probably a little more disorganized than the average lesson, but I think the content is actually, in my opinion, quite a bit cooler because we're actually doing something non-trivial and actually really interesting.
Yeah, it's pretty cool. This lesson.
Yeah. So hopefully we can.
I wonder if like I know it's tough to teach, but I think you did a great job, and I feel like I have a much better understanding. I wonder if maybe like putting into comments in that file a lot of what you were doing as you were like walking through the code would be helpful. Like what each specific, sub like group of functions like is doing,
Yeah, no, I agree. What I'll do eventually is I'm going to try to make this just like a separate. It would also be better if there were multiple files. You'd have a couple. You'd have a crawler file. You'd have maybe a worker file. You could have a database file. If you separate it from different files and go, this is what happens in this file. There's a number of things where I could kind of put in comments what's actually going on. It's a good suggestion. I think in a future version of the class, I'd probably make like an intermediate sized one that's just that doesn't actually save it to the database. It just prints stuff out. Maybe just has like 3 workers or something, and it'd give you really good logging. Like every print statement would say which worker it came from, and exactly what it's doing. So I think that would probably be a little more helpful for like explaining it, but that actually takes quite a bit of work, to make it a really nice program that prints everything out really well. It actually is way harder than it seems. So I'm just going to try to get you. Go ahead.
You're saying you could do that in Jupyter?
Yeah, sure. I could. It could run. We could run this in Jupyter if we wanted, but it's not. Yeah, I probably could. That's probably what I'll do is maybe something that just has 2 workers. Because the more workers you get, it'll just print more. Uh-oh. What version of Python are you using? Gustavo, did you open your virtual environment? Or do you have one?
Oh, no. I forgot about that.
Okay.
Okay. I will try after this video.
Yeah, so if you don't want to use your virtual environment, you can actually do this. Like,
the node don't need, right? When you Python, just the notebook.
Okay. Yeah. So that's another way to do it is if you just point it at that version of Python. But yeah, so that's hopefully it'll work, and I don't know. We can kind of. But this is going to be this is going to be very similar to if we get to the initial block download, if we ever get that far. The program is going to look pretty similar to this, actually. It's going to be damn near the same program.
Of how you complete initial block download?
Yeah. So you just go and have a couple workers. They all just go in a loop of connect. They just connect and just kind of handle as they get messages back. They handle. Actually, yeah. I did. If you guys got a few more minutes, I did kind of neglect. Which one is this? I did kind of neglect. Let me just do it one. So there's one part that's important that I kind of went over. So in the connection, so the thing the connection does is it just goes forever. It just goes until it downloads both the version and the adder message. And every time it just does this, it just gets the next packet, right? And we saw these packets. These are the things that just have a command and a payload. And then it just calls self.handlePacket. And so what handlePacket does is it has this map of different commands. Remember, and we've seen these version, var, ack, adder. These are the commands we've dealt with. And then for every packet it gets, it says, hey, if it's in this little map that maps the command name to a handler, a function that can handle that type of command, if we have a handler defined, let's go and pick it out of our little dictionary, and let's call that handler. So all this does is like it calls a function depending on what the packet's command attribute is, right? Based on packet.command, it will call a handler. And so you can kind of look into the code a little bit more, but that's basically what it's doing is it'll call a handler based on what the command is. And so if you just look at these, if the command is version, that means we're in the middle of the version handshake and our peer is sending us a version packet. It'll say, hey, let's set the version message on ourself, the connection to be the payload. Like that's what will eventually go into this table, right here. That's what will go in there eventually. And let's see here. And so that's basically all that does is it just saves it, and then it sends a verac in response to kind of finish the handshake. And if we get a verac you don't actually need to do anything in response to. But what we do is we send a get attr. This is a message that tells them, hey, we want to know what your peers are. And so I haven't really tested if this actually works, because it doesn't seem like, a lot of them don't seem to give us their peers. But this is just what you're supposed to do if you want to get your peers, the peers of your peer. And then if we get an attr message, we basically just check, hey, this is just a check to like, do we know about this? Are there new addresses here? And this code is ugly, but if there are new addresses, meaning like, because sometimes they just send you a message that just has their address, which is annoying. It's like, why are you telling me what your address is? But if they give us some new ones, then we'll say, okay, this basically saves the version, the payload, and this will make the whole, this is basically will end the loop, because our loop goes here while not self.complete. And all self.complete does is check if self.version message and self.attr message are defined. So if they're both defined, like if we found a version and an attr message, then self.complete is true. This condition, not self.complete, is false, and our connection ends, and then our worker will go on to the next connection. That kind of makes sense? So this is a bit of a mindfuck. This way of handling different packets. Yeah, maybe I'll try to make a slightly simpler one. Just yeah, this is probably not the best way of doing it, but of teaching this. But yeah, this is really important. As we get different packets, we write different functions to handle the different types of packets. So yeah, does that make sense?
Yeah, I think so.
Okay, yeah, I mean, it's more of an in principle thing at this moment. But yeah, I'll have to figure out how I teach this the second time around. But it's, yeah, this is like, we're actually getting to the meat. Like this is pretty close to being a badass program that can do really cool things. So yeah, that's all for this week. And let's, next week, I think what I'm going to do is we're going to actually start downloading. We're going to, much like, so what we do here is when we finish the version handshake, we say, hey, give me your addresses, because this is an address crawler, basically. So what we're going to do next time is we're basically going to do this, but we're going to do get blocks. I think this is what it's called. We're going to send them get blocks. And what get blocks will do, or actually what we're going to do is get headers. What this will do is say, hey, I want all the headers, like the block headers. I want these, and I want you to give me like the complete history of the headers. And then once you finish and get all the headers you need, then you can go and say, hey, give me the blocks. And then you just sit here, and like we handled the attr message, we'll handle the header and the block messages. and we'll be able to start downloading blocks. And the tricky thing is, of course, once we download the blocks, we're going to have to figure out if they're valid or not. And of course, that's the whole magic of Bitcoin. And I don't think our program will ever be able to get, do perfect validation, but I think we can get some of the basics maybe, because you'll have to, there's a lot of work to say if a Bitcoin transaction is valid or not. And you have to do that for every transaction in every block in the entire chain. But we'll make the first step of starting to download headers and blocks in the next lesson.
Sounds cool.
Sweet. All right. Well, that's all for this week. Let's be in touch. Tell me any problems you have running this program, and I'll be making updates to it. And we'll see you next week for start to get some really badass stuff going here.
Thanks, Justin.
All right.
Awesome. Thank you, Justin.
Yeah. See you guys.
Hey, Justin, are we still good for 4 o'clock today?
Yeah. Let's do it.
All right. Yeah, I'm gonna take a break. I'll be back in 30 minutes.
Yeah. Me too. I'm exhausted. All right. Yeah. See you in 30 minutes.
All right.
Bye-bye.